Hello students, today we will discuss the other type of problem when the value of u is not given. Okay, so in the previous class we have discussed with respect to multi-stage steam turbine problems when the value of u is given. So today's class we will discuss a problem when the value of u is not given. Okay, so I will read the problem statement. The problem statement is like this: a two-stage impulse turbine has two rows of moving blades and one row of intermediate fixed blades. Okay. Steam exit velocity from the nozzle is 600 meter per second at an angle of 16 degree. Okay, that is steam velocity from the nozzle, that is V1. Outlet of the nozzle is V1, and outlet of the nozzle is nothing but it represents angle alpha 1. So that is 16 degree, and alpha 1 is 16 degree. V1 is 600 meter per second. Okay. If the discharge angles of the rotor and stator blades are 32 degree and 22 degree respectively. Okay, here discharge angles means it is the outlet angles. Okay, again I will read: the discharge angles of the rotor and stator blades are 32 degree and 22 degree respectively. Okay, so we have two rows of moving blades. So discharge angle of first row of moving blade is beta 2. Discharge angle of second row of moving blade is beta 4. So both are 32 degree. Okay, and with respect to stator, we have one set of stator or fixed blade. So the angle, discharge angle of the stator it is in the second stage. In the first stage it is nozzle. In the second stage you have stator. So the discharge angle from the stator is alpha 3. It is 22 degree. Okay. Let's find the velocity. Find the blade velocity. Means we have to find out the value of u. Rotor efficiency, we have to find out the efficiency, that is work done upon the kinetic energy supplied, that is W upon V1 square by 2. Then we have to find out specific steam consumption. So specific steam consumption means you have to find out m dot when the power generated is 1 kilowatt. So that is nothing but specific steam consumption. So we have to find out m dot when the power generated is 1 kilowatt. Okay. So assume that 10% loss takes place both in stator and rotor blades. So 10% loss in stator as well as rotor blades. The meaning is from when the steam enters from one of the blades, say moving blade, rotor, from inlet to outlet, it will lose 10% of the velocity. So that is nothing but 100 minus 10, which is 90%. So if the inlet velocity is say 100 meter per second, when it is coming out, it will be 90 meter per second. So in the process, it will lose 10 meter per second velocity. So that is 10% loss. So the value of Cp is given like this. So Cp value is 0.9. So it can be written for all the moving blade and stator blades. So I have written Cp is equal to Vr2 by Vr1 is equal to V3 by V2 is equal to Vr4 by Vr3. Okay. So as the value of u is not given, so it has a particular procedure. So we will follow that procedure. Okay. Now one more important thing here, it is given that steam exits axially. Steam exits axially means V4 is equals to Vf4. The meaning of the sentence: steam exits axially means it is V4 is equal to Vf4. So this indicates Vu4, the tangential velocity component is 0 and alpha 4 is 90 degree. So this is very important. Okay. If it is said steam exits axially, so this is the condition. If it says radially, then also we get the same condition. But practically, axial condition and radial conditions are different. Okay. Theoretically, we will be writing the same thing. Okay. Yes. So again, to solve the problem, as I told, we have to follow a particular procedure. So in this case, we have to start from the second stage and go towards the first stage. Okay. For that we have drawn a reference velocity triangle. You can see over here. Okay. So here, if you look at here, so this is the part initially you have to start with. So this is the length of u. Okay. So if you see over here, already it is marked that V4 is equal to Vf4. Further, the angle alpha 4, the nozzle angle or the stator angle which is coming out. So that is alpha 4, which is 90 degree. It is marked over here. So like this we have to start. So this is our reference point. What I will do, initially I have to take as the value of u is not given. So what we will do, we will assume a particular value of u in centimeters. So let's take it as 3 centimeters. Okay, this is the procedure what we have to follow. So as I am starting from the second stage, okay, so this is the line which is representing u, and the line length should be 3 centimeters. The line length should be 3 centimeters. Okay, so I have drawn a line, horizontal line, which is representing 3 centimeters. So what is the next step? We know that V4 is equal to VF4 and it is just a vertical line. Okay, so I draw a vertical line of some random length. Okay, yes. So then this is from one point of the u. So here I can mark the angle alpha 4 as 90 degree. Okay, so we know that this is, if this is V4, okay, it is also known that is equal to VF4. So V4 and VR4, they meet at a particular point. They meet at a particular point. Okay, so it is given that beta 4 angle is given. Okay, it is 32 degree. So if you see over here, this is the line which is representing VR4 and it makes an angle beta 4 with the horizontal. So I know the angle beta 4, but I don't know the length VR4. So what I can do, I can using protractor from this point, I can draw angle 32 degree, which is beta 4. So what I do, this is the reference point. From this point, I use protractor and I mark, or I will draw a line which is equivalent to 32 degree. That is beta 4 angle. So I get this point. This is the intersection point. So this is our, say, beta 4, which is representing 32 degree. 32 degree. Beta 4 is equal to 32 degree. So now we get this reference point, right? So once we get this reference point, so now I can measure this. So this is the length. So from this point to this point, the length we will, if we measure, we will get the value of VR4. Also, if I measure this length, I will get the value of V4, which is equal to VF4. Correct? So now we got the value of VR4. Okay, say certain centimeters. Okay. So the values are already measured. Okay, so here you have now noted down the values. I will be writing only few important values. Okay, so just I will be explaining the procedure. Okay, so if once I get the value of VR4 in centimeters, I can find out VR3. I can find out VR3 using this relation. Okay, so it is nothing but 0.9 is equal to VR4 by VR3. So I will get the value of VR3 again in centimeters. Now, this is the outlet stage. This is the outlet stage. Okay, the extra part I will rub it out. Okay, yes. So this is the outlet stage. When I complete the velocity triangle with respect to outlet stage, I am using this formula. I get the value of VR3. So I know that VR3 will start from this point only, because VR4 is on this side. So VR3 is definitely on this side. Okay, and V3 is on this side. Okay, if this is V4, definitely the other V component, which is V3, will be this side. Okay, so now I have to complete the second stage velocity triangle. So for that I know VR3. What else I know? I know the angle alpha 3. Okay, so I know the length VR3. I know the angle alpha 3. So what I can do is, from this point I can use protractor and draw an angle 22 degree from up to this side. Okay, so you can see over here, this is alpha 3 angle and the length V3, which is on this side. Okay, so again I'll draw this line, or I'll just draw a line which is making an angle 22 degree. The length I don't know, exact length I don't know, but randomly I draw a line using protector which is representing angle 22 degree. That is our alpha 2. That is our, sorry, it is alpha 3. Alpha 3. Okay, it is alpha 3. Next, we know the length. We know the length VR3. Okay, so set this length in the compass. So take the protector and cut the length with respect to this line. Okay, because we know that this is V3 and this is VR3, and when I cut it, we will get an intersection point. So this is VR3. So if I just complete the velocity triangle, I will get the length V3 and VR3 also. So this is the intersection point. You can rub the extra part. Okay, from this point you can drop the perpendicular. So this will represent VF3. Okay, so what we have done, we have drawn this line which is representing 22 degree alpha 3. Further, we know the length VR3. So we have taken the compass length of VR3 and we have cut on this line. Then we get this point. From that point, we have dropped a perpendicular which is representing VF3. Okay, so now what I can do is I can measure V3 and angle beta 3 for reference. Okay, so let's say I have measured VR3, it is certain centimeters. Okay, so from this we can go to the first stage. Now this completes the second stage, velocity triangle. So I can just extend this line. Okay, and I can go to first stage. Again, in the first stage, what I have to do? I have to draw this line which is representing U. Okay, so again, I have to start from this point or this point. Okay, so in this case, you have to start from this point. We will be starting from the exit side, not the inlet side. Okay, sorry, we will be starting from this. We will be starting from this point. Okay, so we know the value V3. So what we will do, we will again use this relation and find out V2. Okay, so CV is equal to V3 by V2, which will give us V2 certain centimeters. Okay, so again I know that V2 is towards this side, V1 is towards this side. So that is visible over here. Yes, from one point of view, from this point of view, V2 is towards left side or towards this side, V1 is towards the right side. Okay, so here I am completing the exit velocity triangle in the first stage, or outlet velocity triangle in the first stage. So I know the length V2. Okay, what else I know? Okay, I know the angle beta 2. I know the angle beta 2. Okay, I know the length V2. I know length V2 and I know angle beta 2. So using this, we can get the outlet velocity triangle for the first stage. So what I have to do? I have to draw an angle which is equivalent to beta 2, which is 32 degree from this point. Okay, if you carefully see over here, from this point it is beta 2 and towards this side. Okay, towards this side. So it is making an angle beta 2. So what we will do? We will draw and using the protector a line of some random length which is making an angle beta 2 which is 32 degree. Okay, so this represents beta 2. Okay, and we know the length V2 from this point it is towards this side. So using protractor we can cut the length V2 on this line, because if you see over here, from this point it is V2, from this point it is beta 2 angle or VR2, they are intersecting at some point. So here also, if I cut this line, we will get the intersection point. So I can join this line. Now this will represent V2, this will represent VR2. Okay, if I drop the perpendicular, I will get VF2. Okay, now I mark the angles. This angle is alpha 2, already this is marked, this is beta 2. So this completes first stage exit velocity triangle point. Okay, from this I can measure VR2. Okay, V2 already we know, I can measure VR2. Okay, VR2. So it will be certain centimeters. Again I will use this notation. So that is CB is VR2 by VR1 and I will find out VR1. Okay. And I know that VR1 is starting from this point and it is towards this side. Okay. So I know VR1 and also I know this angle alpha 1. Okay. Both parameters I know. So what I will do is I will first initially draw this alpha 1 angle towards this side. So you can get the reference of this diagram. So alpha 1 is towards this side. Okay. Alpha 1 is towards this side and VR1 is also towards this side. So alpha 1 will start from this point and beta 1 will start from this point. Okay. Yes. So alpha 1 using protractor you can draw an angle 60 degree towards right side. Okay. Towards this side. So a random length which is representing alpha 1 and it is equal to 16 degree. And from this point I will take the compass length of VR1. Then I will cut that compass length on this line. So this is the intersection point where V1 and VR1 are meeting or intersecting. Okay. So if I drop the perpendicular, I will get VF4 also. Okay. So this completes the velocity triangle. Okay, sorry, this is VF1. So this completes the velocity triangle. The parameters, what all I need, I can measure them. It is beta 1 over here, and I can find out the question which is asked in the problem. Okay, so you have to find out 3 parameters. Okay, so this is how we can complete starting from outlet, and we can go towards inlet and complete both second stage and first stage. Okay, yes. Now it is asked that to find out blade speed, that is U. Okay, so we have taken it in centimeters, but exactly we don't know the scale. So in this problem, we will first find the scale. What is the scale? So how to find out that? Okay, so we know the length V1. We know the length V1. Okay, this length we have solved it already. We have solved the problem, and we know the length of V1. So I will measure this length. Using the scale or any device, you can measure this length. Okay. Okay. What we will do just for now, this is not required. We will erase this part. We will do the calculation over here. So I can measure V1. So V1 already we have measured. It is around 13 centimeters. Okay. And V1 value in meter per second is given, which is 600 meter per second. Okay, so if I divide this centimeter and meter per second, I will get to know the scale. So that is 600 by 13, which comes out to be around 46.15. So for 1 centimeter, scale, we have 46.15 meter per second velocity. This is the mean. This is the scale. 1 centimeter length represents 46.15 meter per second velocity. Okay. Now we have taken U to be 3 centimeters. So U is 3 centimeter. It is when I convert centimeter into meter per second, it will be multiplied by 46.15 meter per second. Okay. So already the value is calculated. This is around 138.45 meter per second. Okay. Yes. So we have to find out work done. Here work done we will get in 2 stages. First stage as well as second stage. So the formula is U into delta VU for the first stage, delta VU for the second stage. Okay. So delta VU is this much length. This is for first stage. I hope this is clear to you people. From this point to this point, this is delta VU, or VU. This is VU1 component of V1, this is the component V1 and component of VU2. Both summation, or you can directly take delta VU for the first stage. And over here we have this much delta VU for the second stage. Okay. So VU4 is 0. As I told you, VU4 is 0. Only it is VU3 which is contributing. So delta VU for the second stage is equal to VU3. Okay. So U value already we have found. We can measure this in these things in centimeters, and if you multiply by 46.15, we will get the values. So already it is calculated. It comes out to be around 150.8 into 10 power 3 joules per kg. Okay. And remember one thing: we are solving all the problems per kg. So this is the first parameter which was asked. Second parameter is the efficiency or the rotary efficiency, which is work done upon the input, output upon input. Input is the kinetic energy of the steam. Work done upon V1 kinetic energy of the steam, which is W upon V1 square by 2. Okay. We know the V1 value, we know the W value. If I substitute and calculate, I will get the efficiency around 83.77%. Okay. Then specific steam consumption. As I told, then we have to take P dot P is equal to power is equal to M dot into VU and delta VU for the first stage plus delta VU for the second stage. If you carefully see, this is nothing but M dot into W. M dot into W. So as I told, we have to take 1 kilowatt power. 1 kilowatt power. So for kilo we have to multiply by 10 power 3. So specific steam consumption means it has to be calculated for 1 kilowatt consumption. Sorry, for in order to generate 1 kilowatt power, what is the steam consumed? Okay. How much is this amount of steam consumed when the power generated is 1 kilowatt? So that is what we have to find out. So I substitute this, then M dot work done already I know. So the value will be substituted. Okay. And if I calculate, I will get the value of M dot to be 6.63 into 10 power minus 3 kg per second. 6.63 into 10 power minus 3 kg per second. Okay. So this much amount of steam will be consumed in order to generate 1 kilowatt power. 1 kilowatt power. So these are the answers. So this is the way we can solve the problem when the value of U is not given. Okay. So we'll meet in the next class. We'll discuss the problems on reaction turbine. Thank you.